In this video, I'm going to explain implicit differentiation. Firstly, the normal functions that we learned till this time, they were called explicit function. The difference between implicit function and the explicit function, here there's a y value and there's a one function for y, but we don't know what is that y function. So if y is equal to fx, then or y to the power of 5 is equal to f to the power of 5x, it should be. And here the important part, while we are getting the derivative of this kind of expression, we should get the derivative of both sides. And generally, for the implicit differentiation, we should collect the terms to one side. Like instead of 0 here, it should be equal to 0. So if you want to find the y derivative, you should get the derivative of both sides, which means y to the power of 5 plus y plus x derivative is going to be equal to 0 derivative. 0 derivative is going to be equal to 0. First I need to mention that one. Then we should write the derivative. The sign is addition, so we should write this derivative to all the terms here, which means y to the power of 5 derivative it's going to be, and y derivative it's going to be, plus x derivative is going to be. Here the important part, y to the power of 5 derivative is equal to what? Because if I know that x plus 2 to the power of 5, then the derivative of this expression, if I ask you, and here you're going to tell this is 5 times x to the power of x plus 2 to the power of 4 times x plus 2 derivative, which is the chain rule, and we have to do like this. F to the power of nx derivative is equal to n times f to the power of n minus 1 x times f derivative x. So y to the power of 5, you are going to accept that it is f to the power of 5. X derivative is equal to 5 times y to the power of 4 times y derivative plus x derivative is going to be equal to 1. Then it's equal to 0. Now I have two y derivative here, and I may send the one to the other side because I need to get y derivative alone. So when I get y derivative parenthesis here, this is going to be 5y 4 plus the in front of the y derivative, the coefficient is 1, it's going to be equal to 1. What happens to this one? This one we are sending to other side, and it becomes like minus 1. Then to get the y derivative, I'm going to send the 5 by 4 plus 1 to the other side, and it becomes like this, minus 1 to the power, over 5 by 4 plus 1 is the derivative of this implicit function. And as you see at the end, the function that we found again doesn't depend to x only, it depends to y also. Okay, here dy over dx is equal to y derivative. So we are going to find the y derivative of this given expression. And as you see, on the other side we have 0 again. So I'm going to get the derivative of this expression like this: y 3 minus y square x plus x squared minus 1 derivative is equal to 0 derivative it's going to be. And this is going to be y cube derivative plus, minus. Normally I can directly get the y derivative because I understood from the f to the power of 3x derivative, this is equal to, we know the chain rule very well, that's why f to the power of 2x times f derivative x it's going to be. So if I replace this one by y, this is going to be 3y squared times y derivative. And I can do this one directly, but I want to show the difference between these two terms. That's why I didn't do that one directly, which is equal to y squared, the second term, y squared times x derivative plus x squared derivative minus 1 derivative, it's equal to 0 it's going to be. And as I explained here before, y cubed derivative it's going to be equal to 3y squared times y derivative. But for the second term, this is y squared times x, and this is the multiplications derivative. It's going to be, and multiplications derivative, if you remember, f times g derivative is equal to f derivative times g plus f times g derivative is going to be, which means this function is going to be written like minus, in parentheses I'm writing, y square times y square derivative, y square derivative times first one's derivative times second one, which is equal to x, then plus first one times y squared times x derivative is going to be, then x squared derivative, we will finish this part, then x squared derivative. I'm going to start. X squared derivative is equal to 2x. The derivative of minus 1 is going to be equal to 0, is equal to 0. It's going to be. Now I finished this part. I'm going to distribute this minus sign inside, and I'm going to get at the same time the derivative of y squared. So 3y squared times y derivative is equal to minus 2y times y derivative times x. Derivative of y squared is going to be equal to 2. It's going to come in front, 2y, and this is like fx function with respect to chain rule. When you decrease the power, at the same time you should get the derivative of the function, which is y derivative. Okay, here. Then y squared times the x derivative is equal to 1 plus 2x is equal to 0. Now the terms with the y derivative, it's going to be on one side, and the other terms I'm going to send to other side. So it means that y derivative times this two term has y derivative, which is equal to 3y square minus 2y. Actually, I made one operational mistake here. When I distribute this minus sign inside, I should make this one also negative. That's why this should be minus y square, and plus 2x, it's same. Then this is going to come to other side as y square minus y square becomes y square, 2x becomes minus 2x. Then to leave the y derivative alone, I should send this one to denominator. Y derivative is going to be equal to y square minus 2x over 3y square minus 2y is going to be. Okay, we found the derivative of the expression. The next one, here, in this question, we are going to first get derivative. Then instead of derivative, this is the first one, we are going to get the derivative. In the second part, we are going to replace the x and y values by root 3 and 1 to find the slope. Because if you remember, the derivative is the slope of the tangent line we set at the beginning, and we are going to find in the third part the equation of the line. Now x squared plus y squared is equal to 4. Then I'm going to get the derivative of both sides, and I'm not going to get 4 to the other side because the derivative of 4 is going to be equal to 0. That's why x squared plus y squared is equal to 4 derivative, which is equal to derivative of x squared is equal to 2x. Derivative of fx squared is equal to 2fx times 2y times y derivative is going to be equal to 0. And the terms without y derivative to one side, 2y is equal to 2y times y derivative. Y derivative is equal to minus 2x, it's going to be, and y derivative is equal to minus 2x over 2y, it must be. And when you simplify, y derivative is equal to minus x over y is going to be. Okay, this was the first step here, and we found the derivative of the function, implicit function. Now in the second step, we are going to find the slope of tangent line, and we know that y derivative here, at the same time y derivative can be written like dy over dx. Okay, y derivative when it's equal to root 3 and 1 is equal to what? We have to find this one. In the second part, we have to find that one, and this one here. Okay, this one is going to be dy over dx is equal to here minus x over y, which is equal to, if you replace the x by root 3, minus root 3 over 1 it's going to be, which is equal to y derivative. Actually, this is not the y derivative. This becomes m is equal to minus root 3 is going to be. Okay, we finished the second part, and the third part we are going to start. Now we found the first derivative. By using the derivative we found the slope. Now we are going to find the equation of tangent line at that point. Equation of tangent line passing through the point here. This is the point. I know the point, it's equal to root 3 and 1, and I know the slope, that's equal to minus root 3. So I'm going to use slope and point form, which is y minus y1 is equal to m times x minus x1. Here y1 and x1 becomes, this is x1 and this is y1 it will be, and this is the m. Also here you know what is the m value, so we can write this equation now. Y minus y1 is equal to 1 times minus root 3 times x minus root 3 is going to be y minus 1 is equal to minus root 3x, minus and minus, it's going to be plus, then root 3 times root 3 is equal to root 9, which is equal to 3. Then if you collect all the terms to one side, root 3x plus y minus 1 minus 3, when this comes to other side minus 3, it's going to be 4 is equal to 0 is going to be the equation of the line. Or you can say or y is equal to minus root 3x minus 4, also equation of line can be written. This is the last question. One more time we are going to repeat the implicit differentiation. X cubed plus x squared times y plus y squared is equal to 5. So if you want to get the implicit differentiation, we should get the derivative of both sides. So I'm going to do like this directly here. This one's derivative, it's going to be, then this is x cubed derivative plus x squared times y derivative plus y squared derivative, it's going to be, and it's equal to 5 derivative is going to be equal to 0. The constant terms derivative is that one. Okay, then this is going to be 3x squared, but this is the fx function, so you should find the x squared times fx derivative normally. And if you have two different functions, the multiplications derivative you should use, and x squared times y plus x times x squared times y derivative it should be, because f derivative f times g derivative f times g derivative is going to be equal to f derivative times g plus f times g derivative. This is the multiplications derivative. So x squared times y, x squared times x squared derivative times y plus x squared times y derivative plus y squared derivative. This is fx to the power of 2. You can accept like that, and I'm going to apply again chain rule. 2y times y derivative is going to be equal to 0 here. Again, I'm repeating. In the previous questions I repeat this part, but for the chain rule, let's say y to the power of 2 derivative is going to be equal to 2y times y derivative, because f to the power of 2x, if I ask to you, the derivative of what it is 2 times fx, you're going to tell me you're going to decrease the power and it's equal to 1 here, times f derivative x it should be. So 2 times y derivative is the solution of this part. Okay, now I'm going to get the derivative of this one only, 3x squared plus 2x times y, and plus y derivative times x squared plus 2y can be is equal to 0. So these terms, they don't have the y derivative, that's why they're going to send to other side. Y derivative is going to be equal to y derivative times x squared plus 2y. 2y is going to be equal to minus 3x squared minus 2xy. Then y derivative is going to be equal to minus 3x squared minus 2xy over x squared plus 2y.